her about
Yeah.
some stuff that she's got going right now.
Last time we
Alright.
talk about normalize, right? With Harper. Normalize thing. Not sure.
Yeah, so one of the things I'm trying to do also, so let me just start, I guess. We got a mess here with all kinds of shit all over the place. I'm talking to court, so Tim quit. Okay. And with Tim leaving, it kind of opens up this core facies thing for us a little bit more. So he was sort of, I don't know what you would say, protecting that stuff a little bit. Hold on one second. Send something to Harper here. Anyways, sorry. So he was sort of, this happens at corporations where guys like Daniel have done this as well, right? They like to control things because it makes them look important or whatever, right? I don't want somebody else running behind me and doing all this work to make me look bad. I want to control. It's mine, not yours. And they take it like little kids, right? That one's mine. And they put it in their toy box and lock the toy box, right? And then what ends up happening is nobody does anything with that. And then 3-4 months later, it winds up on our desk anyways. So that's what's happening. Tim kind of grabbed some of this core stuff that I had started with Sebastian, right? And
Whoa.
Oh my God.
he and Corinne, they said, hey, we're machine learning people. You're not. This is ours. We're going to do it. And they're employees and I'm a contractor, right? So anyways, it disappeared. Well, Tim quit. So I asked Corey just now at 9 o'clock or whatever, I said, hey, we've got an engineering intern that's wants to play with Python and do, core stuff. What do you think about, letting us have a look at that data? And let's not do an intern project, or let's not waste time just doing exercises because it's fun to do exercises, right? Let's actually do work in the process so that, when we're finished, we have a whole bunch of good work that's been done, not just learning academic type stuff, So he's going to talk to Dave and he's going to talk to Mike, and I think that we'd be able to work with that. There's I'm just looking 187 WellCAD files, 136 wells, 119 are from the tight oil reservoir Midland Basin thing. There's full core descriptions for those. 14 are from the Bone Spring, 82 are from the Avalon, 34 from the Wolfcamp, Texas study, and then another 25 from the Woodford Barnett Shale study. So that's more than 187. I don't know how he got that. It looks to me like over 260 different wells that would have full core descriptions, right? So then what we would need to do is use our Python skills to digitize and convert the data. So the WellCAD files, we'd have to open those with WellCAD, export to ASCII. But the problem is we need to convert between the Core Lab facies and the Diamondback facies. So Core Lab has got 35 different lithological depositional based facies, right? They get very specific about how they define things. We don't give a shit, right? We're not going to differentiate some of these things. So, we want to use the 8 facies that Sebastian defined, which is essentially like a gray shale, a black shale. So inorganic, organic, carbonate, right? Like a general dumpster for packed stones, root stones, all that stuff, right? That kind of all goes together. Then there's a silt facies, a sand facies, and there's one other dolomitic facies or something that we never see. So really there's not even 8 facies, there's 6. And that is now a number that is at the level that we can resolve it with the number of log curves that we have. So Sebastian and I already did this, right? We ran the MLNet program that I wrote and used the Light GBM multi-class classification algorithm and got fantastic results training the wells that were described by Sebastian. The problem with that was that of the 20 wells that we had, 19 of them were from the Delaware Basin, because that's where Sebastian was working. So we had basically no data from the Midland Basin, which was a big problem. So that's where we've got all this supplemental data now. Like I've been chasing this down for probably 6 months, right? Where we tried to get the licenses to WellCAD so that we can open these files and get the data out of it, right? And then we will need to convert them. So we'll have to write some Python logic scripts. So basically, you know, there's rules that Sebastian put together. We have a document, right? It's got some different logic rules, but it's very basic programming. It would take me 5 minutes to do this, right? Just write up a script, and then it's going to convert all these 35 into 8. And then once we get that big data set, then that's when we start doing all the data science stuff that Tim would do or Corinne would do, you know, with that data to understand how far we can push the log data to resolve some of these facies, right? So how many false positives do we have, right? Stuff like that, looking at accuracy of the measurements, you know, the overall uncertainty in the measurements, right? And then kind of translating that through the whole chain to the predictability and being able to resolve facies that are sometimes defined at very fine resolution, well below what the logs can see, right? And then if I was going to do a full study, like if I worked for the government and I had a $1 million budget in 10 years to work on it, right? I would do sensitivities as well to say, like, what happens if, you know, I've got my logs off depth? What happens if I got something wrong with this? How does that impact my model? Does it predict totally different facies? Like if my gamma ray's off by a little bit, do I get all sand instead of shale? Like that's a problem, right? That's a model that's not useful. And it's very scary and dangerous because, you know, I'm making decisions based off of things like that. So anyways, that's what I'm working on that end. We'll see what happens with it. The Harper thing is like super secret. I can't even tell you about it. And I'll work that stuff. And then we still need to get Daniel's stuff done, right? Like I've been sick over the weekend and I've had a bunch of personal problems with my family. They you know, my dad was almost died. He was just admitted to the hospital. We had to call an ambulance and everything.
Oh my
So
God.
I've been dealing with all that shit, right? Like, so I haven't had a chance to look at the Daniel wells yet. So, you know, I want to do that before we ship it out. I didn't look at the wells for Jorge, but I just gave them to him. So hopefully there's nothing wrong with those. And that's just the editing anyways, right? That's not the full analysis. So
Yes.
no worries there. We've got some other stuff as well, like with the project that came the other day, right, from Ben. What they want to do is understand, you know, how many wells they have that they think they can do solid interpretations on in the Barnett Woodford. So there's like 850 wells, I think, that he sent me. And out of the 850, like 287 or something had petrophysical interpretations in their system, which means that somebody did a PA at some point. It may not have been us. It may not have been Diamondback. It may have been QEP or some other company, but we have some sort of PA. And so instead of trying to work with all of those wells that have nothing, you know, where we have to rename everything and we don't even know what kind of data sets we have. What we're gonna do is look at these 285 first. And so the purpose of this, we don't need to go in there and do anything to the data. We don't need to depth shift it. We don't need to edit
Yeah.
it. We don't care.
Yep.
All we need to do is load those tops, which I sent you the program already that can do that. And I think Tube already jumped on that as well. So we have
Yes,
another way
already
of doing it.
finished. Yes.
Finished, yeah. So
Yeah.
we load the tops and then all we have to do is make some maps. The only trick part of it is gonna be some of the wells may not have the curves renamed to the right mnemonics,
yes.
or they may have the wrong mnemonics. So
Yeah.
we'll have to go
Mhm.
into those things and fix that up. But then after that, what you want to do is stitch together a PowerPoint
Mhm.
that shows the overall data quality on
Mhm.
on like an absolute scale, right? We have to make an absolute scale to display it on, meaning, you know, if one well is a little bit washed out, right? You know, depending on which wells we group that together with, it can look very different on a heat map. If we lump that little bit of washout well together with all the good wells, it shows up really bad, right? And then everyone says, well, throw it away. It's a yellow dot or a red dot. But
Yes.
if we lump that well together with the worst wells, it looks really good, right?
Mhm.
So we need to establish an absolute scale to do some computations on. And what I mean by that is, like, if our bulk density is washed out in the Barnett, at what point does it become so bad that we can't do anything with it anymore? Okay?
Yep.
That's what we need to figure out. And you know, we will make these heat maps up front. I think we may need to make some modifications or bring it into the new program where I've already made those modifications where you can change the scales and stuff. But we need to make sure that all the displays that we make are absolute in magnitude, right? So if we just look at bulk density, you might say, you know, gee, it's 0.3 grams per cc. Like anything greater than that, we can no longer use this data.
Mhm.
It's probably going to be less than that. It's going to be like 0.15.
Yep.
Right? But say that's the case, right? Then you have the problem, okay, well, how much sonic? Right? How much sonic is to the point where it's gone? How much PE? How much, you know, neutron? So let's play with those things. And then what we can do is run the cutoff module as well. And we can look at the total amount of footage per zone normalized to the footage of the zone that's washed out, right? So that's going to be another indicator that we can present to say, well, the zone is 100 foot thick and 10 feet of it is washed out beyond the point that we think we can repair it. So that means that 90% of the data is good. Yay. Or it might be 90% of the data is bad. That well gets tossed, right? We don't want to use it. It's not usable. Where the 50% mark, like maybe we can still do something with that, right? Because we have half of the data to reconstruct the other half, you know, but like once we get beyond the 50% mark, we're getting into really sketchy territory. And it's going to depend on two things. One is how far off is it? And two is how much data do we have to train a model with? Right. And then the other thing that we want to do with this study is we want to look at the variability. So histograms, right? The variability, the FHI, that formation heterogeneity thing, right? We want to look at how much these wells differ with each other. Because if you want to go down the road of building multi-well models, right? Multi-well machine learning models or whatever to predict data, we need to know how much variance we have. Right? You'll be able to see that in the box plots as well when you build this out. But we want to document that as a point. We want like one slide, right? here is the variance in bulk density, neutron, sonic.
Mhm.
So like, if you're gonna go build models, be prepared for this, so we have to be extra careful about that, right? And that also means that we want to look at the variance in the data that's been flagged as good, not the bad. We also want to look at the bad too, but we really want to look at the good. So there's a whole bunch of different things that we need to look at in this data set, but that's all we're doing is we're just looking. We're not doing anything else to it. We're not going to edit any wells. We're not
Yeah.
going to,
All right.
just looking.
Mhm.
Okay, so that's it's the core faces thing. I gotta get feedback from Corey for the 285. We're going to load tops. We're going to make plots. We're going to maybe write some custom software as well to do some of this work, right? Looking at cutoffs, net to gross, bad hole, and histograms for feature, heterogeneity index, and variance by good and bad. So this may be the time as well to get you all acquainted with IP's user programs. I think we tried to do this maybe before, and I think I put a program out there already. Did I not? It's called Python example. Yeah. So.
I see.
So in the IP program, right, this is how this works. So to pay extra careful attention, because this is the world that you could be living in, like you can create these user apps, right? I told you before you can do the Jupyter notebook stuff and all that, but really what you want to do is you just want to create the user app. You can edit the user app, right? So when you create it, you edit it. The way that it works is you specify, it's like an interface, right? You specify the curves that go into the app. You specify the names of the curves that go out of the app. And you specify the input parameters that come in and out of the app, all these different operators, whatever, right? And when you create the user program, what it does is it generates these Python files for you. Okay. So like some of these you're never going to touch. You don't touch this method one, right? If I open this up, it's going to show me inside of here. It says do not manually edit. This is created by IP. These are different helping methods, right? Helper methods that interface with the API to get data from curves or whatever. We don't care about these. We're never going to use these until you get into the advanced programming bit, right? What you're going to do is edit this thing called users Python code, right? This is where you put your user program. So, you can do some stuff here where you connect to the API, you connect to the database, you can get a well list, you can do a loop through all the wells, you can look for curves, right? You can do whatever computations you want in here. You can even write back to IP. But in this case, I think all I did with this little program was built went through, grabbed neutron density and a zone set, formation top set that I hard coded in there, right? And then I said for every single zone in that formation set, each top, find the top and bottom of it. And then what we're going to do is we're going to take these curves, right? We're going to look at the difference between the two of them as this, the curve one minus the curve two or whatever. And we're going to add it to this record here, right, as an absolute error. And then I come down through here and I'm gonna do some plotting, right? And that's it. So the idea here is that you put a depth shifted curve in and then you put the raw curve and you're looking at the difference between the two. Right? So if I like open a well here in this Barnwood project, I don't know, let's grab one. It's got data in it, like this one here or whatever, Penrose, Oldham. I guess it's somebody named Petro's got that on. If I run this. It's going through all the friggin' wells in the database. What it's doing, even though I only have one well open. So that's one of the other problems you have here is that we don't define that here. We get returns all of the wells that are says that are open. Okay. So this thing filed, I guess, I don't know. How you run it. So. So it looks like they changed the API or something. I don't know why it's not. Well, there, maybe there's no tops RB in here. Is that what it is? No, there isn't. All the tops are gone again. Piece of shit, right? Like I've had this problem, I don't know how many times now. Where I get in these things and it deletes all the parameters. There's like some bug. This one's got it. I don't know what's wrong with the other one. So let's try this again. There it is right there. That's the problem. None type object. I think what's happening is it's still going through that one. Or one missing. All right, now we're getting somewhere. Or one missing, so there's no raw row B. Let's call it like that. Okay, now what you don't see is what popped up on my other screen over here, which appears to be garbage.
Mhm.
So there's something wrong with this. Okay, we got data there. And I guess the curves are identical. There's no depth shift. So that's why it came up like that. So let's find a well that's actually the depth shifted. I know this one has, but awkward son of a bitch. This is a bad one, super bad one. All right. So we got row B, we got row B. So now all I gotta do is get rid of that thing. We'll do this again. And this time it should show something other than this. Boom. Okay, there you go. Yeah. So now this Python program created this web page, right? Just like that. Kind of pulled the data from IP to do it, right? So now that you're an expert already too, right? You can come in here and you can do all this work you just write the IP user program. All you gotta do is just copy this example. Right, you can go into the file folder here, just copy the thing and paste it as a new one. Right, go in and edit it, edit the source code, make it do whatever you want. Right? But this is, let me see if I can find the. This was a bad well. I remember this well. I never forget the bad ones, you know? It's just like a really bad girlfriend or something that tortured you. And you'll never, or like a divorce, you know, like your ex-wife, you'll never forget that ever. And I never forget these wells because they have tortured me. Okay, so we'll do the raw and then we'll do the, yeah. I think this is a bad one. Yeah, you can already see how far off depth,
Oh,
right?
oh,
Look at it.
obvious.
I once had a girlfriend that threatened to kill me when I went to sleep. She said she was gonna wait till I went to sleep and then cut my throat. That's, yeah, it's not really funny though, really, it isn't, when you have to go through the house and
really-
hide all the kitchen knives in there. Yeah,
Oh.
what an interesting life I've lived, huh? Um, but yeah, you can see how messed up this is, right? This is the girl that threatened to kill me in my sleep, right? Look at it, it's okay
Huh.
here. And the strong, and then it's all messed up here, right? And then there's like missing data. We had to make up data or something, I don't even know, right? Like raw data is gone, only have to. I think there was a density porosity curve or something, here it is, E5. So there's like density porosity, we had to convert it. And then it's missing, like on depth, off depth again, like by a lot. Right? This was an awful well. So if we compare that well to another well, and I don't know that that program does that. I think it just. It does break it up by well, I think. Let's add another well on there to compare how bad it is to Parker Trust. There it is. Now, Parker Trust has got nothing in it.
Trust.
Why has it got nothing in it? Why do we hate the Parker Trust? I got no real beaker, is that why? Why? No, I do. I've got no tops. Got tops. Why do you hate me, Parker Trust? I think actually. The numbers are so small that you could see them, but you can't see the.
Oh.
Where's
Yeah.
the little symbol? No, go away. Zoom, zoom. Zoom is dead. Run it again.
Maybe it's
Oh,
my head.
there it is. I see there's such small mean absolute error compared to this other well, right? That's got like mean absolute error of 1 million or whatever it is. That's, you just can't see it. That's how bad that thing is, that head rate. So anyways, this is how you do IP to Python. So examine that program and make some of your own. How much fun is that? That's fun, right? Yeah, yeah, it's fun. And then, like I say, we'll try to get you a real core data set here to do real work and present it to Diamondback instead of just playing. We can actually as they say, two birds with one stone, right? And then, what else we got here? What are we missing? Are we missing something? No missing? I don't think we're missing. Oh, the frac thing.
Okay.
If you want to look at that, it's gonna be next week. We'll be pumping the defit on Monday or Tuesday. Mr. John is going to be giving the next SPWA presentation. So like at this point, Bangkok SPWA is just PetroRes. That's all that it is, right? So plan on giving one as well. Like we'll probably give like 3 or 4 talks this year, right? We just dominate. Fuck SLB, right? PetroRes. But he's gonna be doing a remote talk, so we can just all log in, and I don't know. There's no reason to really come to Bangkok, I don't think, for that one. Although I did suggest that we have a pizza party, and they did, Andrew was mulling it over, but I said, if we end up with pizza, I said, you realize that it was the engineers that made the pizza happen, not the fucking geologists, right? Geologists, no pizza for geology, but engineers get pizza. And he made the comment, well, if we have pizza, it's because we need to have pizza to have people come and listen to a stupid engineer. And I said, well, that's not really fair, right? Anyways, we'll see what's going on with that. And then for the rest of the stuff that's going on, like I've already talked to Game, and the stuff in Houston, I think, is pretty squared away at this point. So we'll just proceed with that as planned. Catman started this
I
week.
see.
I've got him looking at some things. But I haven't had time with everything going on that I've got going on. I just haven't had time to spend with Catman. Which I suppose we should stop calling him Catman. Unless he likes it. We can continue to call him Catman.
Yeah, his name Catman.
It's Ati Pong.
Yeah, nickname.
Am?
Yes, I'm Ken.
Like and Sarah Am?
Not
Yeah, Ken.
Huh?
I'm
ARM.
Ken. Yes. I'm.
Arm.
Oh,
yes.
good. I
Well, it's the difference between arm and am. Like, I mean, come on, right? Like you Thai people, right? Come on. Like,
bad.
like, for me, right? I'm hearing 2 things. I'm hearing and right, something like this. I'm hearing that, right?
Yeah.
So that's not equal to arm.
Why you decide to hire him?
Chen then.
Why not, right? Like, I don't know. These things are never gonna happen unless, we make some effort. And if you fail and you try at something, it's better than just not trying, right? And like tonight, for example, I just got back before like 9 o'clock. I was at a social event here in Bangkok, right? I'm trying to pick up on some of this stuff now. where like they've got these meetings that they hold. This one was called Asia Pillars. It's specifically designed, like you sign up for it if you're an executive, like CEO or whatever, or a founder, entrepreneur of a company. That's who goes to the event, right? So I wanted to see who hangs out at these things. Like, I don't know who's in there. Is it like some fat British guy that's a bus driver that opened a bar in Pattaya, you know, like Bob's Beer Bar? Like, well, I'm an entrepreneur. You know, he's not an entrepreneur. An entrepreneur is something very specific. You know, it's a visionary person that's come up with something that nobody else thought of, right? And is like changing the world. That's an entrepreneur. A guy that opens a beer bar in Pattaya is nothing more than, you know, he's still a CEO though, right? Like, I'm a CEO because I opened a beer bar. I'm the chief executive officer of non-employees, beer and shrimp. Also protected and owned by the Rayon Mafia. But it wasn't bad, right? Like, I didn't have a whole lot of time to hang around. I only had about an hour and a half in there and I had to leave. But I did meet a number of interesting people. You know, I was hoping to meet some software people, you know, and I didn't really. I met some French guys that they do cybersecurity and IT shit. And I met a guy that's doing like data farms, right? And I met another guy, but no programmers. No software shops.
different.
Although interestingly enough, I met a lady. She was Thai. She's the first person I talked to when I went there.
Mhm.
And I got her business card here somewhere. I forget her name. But she's an HR executive for one of these companies around here, like, you know, does HR stuff. But she asked me what I did, and I said, well, I'm doing software. And she says, oh, really? I used to do software. And so I started talking to her. Turns out she's got a degree in computer engineering. And she worked as a computer engineer for quite a while, yeah. And then got into HR somehow. I don't know how you make that transition. That's like kind of backwards in my opinion, but whatever. And she said, yeah, I used to manage software projects, like big software projects and stuff. So I was kind of thinking to myself, like, rather odd, that you know, you now are an HR executive, but whatever. Nonetheless, like, I got her card, right? Like, I could talk, maybe grab a coffee with her or something. I don't know, like, to see, you know, what she could do to help, if anything at all, in that space, right? You know, originally that's what Best was supposed to do. You know, she was supposed to fill a role of learning how the software works, doing all the petrophysics, and then helping to manage the development. But Best ended up doing nothing, right? Like, none of the above. She just sat around and played administrative assistant, which was not useful at all. So we'll see about Catman arm. You know, if he does a good job, then we find some more programmers and we get going, right? If he doesn't do a good job, then we find another Catman. It's sort of that easy, I think.
Okay.
But I did set up a chat with him, right? That I added all of you to. So he says, you know, that as he's looking through the code base and stuff, he's going to have a lot of questions about how these things are supposed to be used. He doesn't know anything about petrophysics. So if and when, you know, he posts questions in that, just go ahead and answer him to your best ability. If he needs a reply, you know, he's going to say, like, how do you load data, or what do you do with these cross plots? Like, how do you use them? I don't even know what they are, right? Like, what's a neutron curve? Whatever, just help them out to get them moving on that.
Yeah.
And we'll see what he can do, right? If he does absolutely nothing in the first month, then, you know, we can get rid of him. If he blows us all away and rocks our world, then we have all kinds of little baby cat baby kittens.
Right here.
Kitten man.
Kidding.
What else? Oh, I met this French girl too at the thing. And I was thinking to myself, like, you know, smart CEO of a company and all this stuff. And then I asked her, I said, so what do you do? Like, oh, I work for an ESG company. I was like, oh, fuck. You know, what am I supposed to say now, right? And I just had to come out with it, right? I just had to say, I work in oil and gas. So your job is to capture the carbon and get rid of it. I'm the one that makes it. Right.
Opposite.
Opposite, yeah.
Opposite side.
So we had a short conversation. She smiled and I left. I don't think she, but nonetheless, it you know, brought up an interesting thing. I did tell her this too, right? That, you know, the reason I mention this is I want you to realize it as well. You know, the idea that you know, petroleum and oil and gas is an evil business is completely unfounded, right? It's absolutely essential for the developing world. And even the developed world, right? We all look at what happened with the Strait of Hormuz closure, right? That brought the world to its knees, basically, if you cut off the oil. And that's not even all the oil. That's only like 20% of the oil, right? You know, we need to have energy to keep lights on and to have refrigerators and all these things. And the bad rap that a lot of these oil companies get is because of shit like Macondo and, you know, some of the things that have happened in the past where there's been really poor oversight, technically, really poor governance and guidance, and accidents happen, right? They spilled all the damn oil in the Gulf. I think this has happened at least a couple times since I've been in Thailand, right down in Rayong, where they've had pipeline leaks and other shit.
Yeah.
Like that stuff, you know, is sort of unacceptable. There's a way to prevent it. It requires spending money to prevent it, right? You have to do preventive maintenance. You have to, you know, monitor pipelines and run pigs through them and do all these things, stop production, do that. But ultimately, our job on the technical side, right, is to do the most efficient possible work to make the best use of the resources that we have. Because what people don't understand, like I told this French girl, is, you know, in the Permian Basin, and let me just, this is dad moment, right? Telling the children a story. But this is what happens in the Permian Basin.
Right.
Okay, this was a cat talk, I think. All right, so we'll go back into this. So this is the Permian Basin, right? And what ends up happening is you've got a finite resource, okay? There's your trees, you know, you got like the billy goat or something, he's hanging out there, having a good time, eating some grass, right? You've got a finite amount of resource. And there's oil down there, okay? There's two ways of developing this resource. One is I come in here and I drill one well there, I drill one well there, I'll cattywampus, right? I frack them all, whatever. I end up draining like, you know, some volume of rock that looks like that. The problem with this is once this shit is depleted, right? Once you've drained it, you cannot just come in after the fact and drill another well here to get the stranded oil. You can't. Okay? It's going to frack into depletion. You're not going to stimulate the well. You're never going to get the oil there. You're done. So the most efficient way to drill the resource, right, might be something that's engineered, right, that looks like whatever, so that, you know, this finite resource that we have, we've only got one of them. right? Once you do something to this rock, you cannot come back to it. It's done. So this rock, this thing here, maybe you get 500,000 barrels of oil out of it, and that's it, right? This one over here on the right, I stimulate all of these evenly, right? I do a good job of fracking everything, right? And I completely, fully drain this volume, right? This thing could be like 3 million barrels versus 500,000 barrels, right? That's the difference. Right? And the work that we do, whether you believe it or not, we're always driving to this. We're always doing everything that we can better to get to that answer instead of doing what's happening over here from Billy Bob, right? Some uneducated guy or a shitty oil company that doesn't spend money on technical staff, right? They're doing this. We're doing this. This is better for everyone because one, we more efficiently manage the in-ground resource, right? So that we get all that oil out of there that future generations are going to need. You know, we're not wasting anything. And two is we're making more money, we're more profitable. So like everyone wins by doing it that way.
Yeah.
Versus doing it that way. And this problem is incredibly complex because you've got wells that are fracking out of order, fracks are going all over, you know, like trying to do all the engineering analysis. That's what I've spent my career doing, is trying to figure this all out from all of the different, you know, physics-based and science-based measurements and calculations and petroleum engineering stuff that we can do to figure out, you know, how to best extract it. So, you know, the French girl may see me as a bad person that's doing this over there. Maybe the students at Ken University see that also, right? And they say, I don't want to work for that company because they're raping the earth, right? And destroying it. But really what we're doing is this stuff over here, right? I would never advocate for this ever in a million years. If a client, you know, came to me, I would never tell them to do that. I would rather not have a job, not get paid, whatever, than to tell someone to do the wrong thing, right? Something that's irresponsible and stupid. We don't do that. So, you know, keep that in mind. I mean, I know like this girl, right? I don't know what she does. I have her business card somewhere, but she's got some firm that she's the CEO and founder of, right? That does carbon capture, sequestration, and studies, right? ESG studies on sustainability, right? On you know, how much carbon can we capture? How much carbon can we make? How do we, you know, stop the earth from burning into a cinder and we all die? And, you know, ultimately the problem with all of that is people. There's just too many fucking people, right? That's the problem on the earth. We're overpopulated. Whether people want to admit that or not, we really are severely overpopulated. We should have a third or a fourth of the number of people that we have. And because of all those people, they're using energy and resources. And because of all of that, it's creating carbon, right? So I don't know any way around it other than like mass sterilization or genocide, right? Either kill the people or stop them from reproducing. That's all you can do. And, you know, in the meantime, between now and when the earth falls apart and is destroyed and everything dies, this is where we sit, right? We're in here trying to do the best that we can with what we've got. So, you know, you could get on your soapbox of ESG stuff and say you're oil people are evil. And you can play the opposite and say, look, you know, I'm trying to improve the situation the best that I can with and to be honest, I have a bigger impact than the ESG girl does, right? Because I'm actually convincing or telling oil companies what to do. And she could scream at the top of her lungs, but nobody's going to listen to her, right? It's true. It's actually true. The best way to do it is to get right next to the guy and whisper in his ear, right? If you tell him to do something and he trusts you, he'll do it. And if you tell him to do the right thing, he'll do the right thing. So I'm not, you know, I don't feel bad about the industry that I work in. I think the work that we do is a very good work. And we do have the ability to make positive changes to the environment more so than the ESG people do.
Mm,
So
me
anyways,
too. Yeah.
there's the speech, the soapbox speech for the day. All right. So anything else?
Alright.
We need to
Yeah,
review the Daniel Wells.
Yeah.
Yes, and then
Yes,
we
we
need
need.
to look at it. But other than that, anything else?
No,
No?
no,
All right, so I'll update you whenever I hear anything next from Diamondback. Continue working on the opinion thing as well for Eric.
Yeah.
And like I say, this Barnett project sort of dovetails into that quite nicely because you're gonna have to do that for Eric anyways, right? And we do it for Diamondback at the same time. It's the same formation.
Mhm.
Ah, how about
Mhm.
that? What a coincidence.
Uh,
Ugh.
let me die.
All right, anything else? Comments, questions, concerns? You want to know the French girl's name?
Yes.
Get the business card. I'll get you the French girl's name. A lot of French people at this thing. I was surprised. They were almost, I think I met like 4 or 5 French people out of the whole, like, and I only met like 10 people. Half of them were French. Her
Oh,
name is Lucille Chariot. Charia? No, I took French
Lucille.
now and I can't even pronounce it. Charot. Lucille Charot. So the
How
way
many
that you write
French
it,
friends you have?
I have no French friends.
Oh.
And she is the CEO and founder of Agence de Tunan Ltd. Based
Uh-oh.
out of Hong Kong.
Little bit hard to pronounce.
Lucille Charot, Agence de Tunan.
A little bit Thai.
Yeah,
Let's
well,
see here.
เรียนภาษาฝรั่งเศส3 ปีแล้ว well, I take it, right? But
Oh.
me type her
You take
see
it?
Google here. Et today français. Mais je pense. She's on ResearchGate, so she's published. Faculty of Political Science, Chulalongkorn University. She's a professor there. So it says she's a professor at Chula.
Oh,
Political science.
wow. Small world.
Small world.
Yeah.
And she
Small
says, what does she say? She says carbon neutral. She's working on China's carbon neutrality. And there's a Chula digital article that she wrote here. It's a thesis and dissertation. It is,
You see,
I think it's her thesis. 2020, she got her political science
6 years.
master's degree at Chula. I don't know how the hell she did that. Do they do classes in English?
Wow.
Or either that or she's fluent in Thai. I don't, that's something else right there. This girl, I'm actually interested in her now. I'd like to learn more. Got a master's degree from Chula. Bizarre. Anyway, it took a strange turn, didn't it? The other guy, Clement, and there was one guy from Marseille, another guy, a Parisian. I don't know. There was another guy too, another French guy. They're all French. All the fuckers are French at these things. Because I was talking to his wife, and his wife was Thai, and
Mm.
she said she moved to Paris and married the guy or whatever, and then they came back here, and I think they were looking for something to do, so they started a company. And what she decided to do was, she said, I drank a lot of wine when I was in France, and I drank a lot of wine when I was in Thailand. And I noticed that the same French wine that I was drinking in Thailand tasted like shit, but it tasted really good in France. And she said, I realized the problem was that they put the wine on boats and it's not refrigerated. So it gets really hot. And when it gets hot, it destroys the wine, right? It's like food. Wine is food. So if you get it too hot, it like breaks it down, and like all the aromatic compounds in it and flavonoids or whatever the hell they are, right? All that stuff is destroyed, and you wind up with like shitty wine that your government then taxes at like 300% as a luxury product and sells to stupid Farang for 1,000 baht a bottle when they paid $3, 100 baht a bottle for it in France. So this lady says, my husband's French. He drinks wine. I'm like honorary French. I drink wine. I'm going to import wine from the French vineyards in France, and I'm going to properly refrigerate it during its journey so that when it gets here, it doesn't degrade. It tastes just as good as the stuff off of the vineyard. So that's what she does. Pretty cool, huh?
Cool, yeah.
I was like, you made a job out of that. Like, that's actually, I'm jealous, right? Like, why can't I do that? And then just go around to all these little events and just drink wine at them. That's my job, because I'm the wine person, right?
My person.
Yeah. Yeah, like her husband, he doesn't do anything, right? He's like, yeah, I work too. I thought it's a business, like he's just sitting there drinking wine. Like he's got a wife that does everything, makes all the money, and he just sits around and drinks wine. What a life. I got to get in on what these French people are doing. They got to, Americans are stupid. They work really hard to make a little bit of money. That's a well-known fact in the world. The French are the laziest out of the batch. So whatever they're doing, you got to do what they do, because they find the easiest solution. Least amount of effort, maximum amount of profit. Yeah, that's the French. All right. Carry on. We'll talk. If you need anything, let me know. Otherwise, I'll let you know when I get data here. And then so just chip away at those projects. And two, play with IP, right? Now that you know how to do that. Let me know if you can't get access to that source code, but you should be able to, and then start to write some programs to work with the IP data. And maybe we can have you help with this 285 well project, right? We can make some cool dashboard charts, whatever, of easier, better stuff than that program that I've got, right? Where, like I was talking about earlier, we look at the net footage and stuff like that, cutoffs, we could write some
Yep, yep.
Python
Oh, yeah.
program to quickly do that over the tops. Yeah, we'll see. A lot of opportunities there. All right. Bye-bye.
Bye-bye. Take care.